There'll be a bunch of us sharing our work today. So the title is Data Provenance in a High Security Research Environment. Basically, I'm very interested in open science, and I completely believe that you can't really do rigorous research unless you're very transparent about it. Otherwise, it's basically unavaluable. Nobody actually knows what you did. So in my ideal world, I would share the data and all the steps I use to do processing, analysis, and let everyone else judge the work on its own merits. But the trouble is, like many of the people in the center, I work with NHS data. So that's patient data. They've not consented for it to be used in research. And the only legal way we're allowed to work on it is if we do it in these high security environments, also known as safe havens. And I can't see the raw data. A whole bunch of processing happens on the other side, the NHS side, and I get a small extract that's been anonymized. And so I'm just a researcher, but sort of interested in open science and thought, there has to be a better way. I really want to be able to show the entire pathway that data traveled before I publish my paper or something like that. And so there is this field called data provenance, basically. I'm completely naive about it. So a group of us got together and we have a small grant from the Wellcome Trust from their open research funding, which is actually a great stream of work. And our fabulous team, so from all parts, and it's proper team science. I was saying, like, I really, really enjoyed it. Everybody here, different strengths and different like profound weaknesses. So Bernhard Schaliga basically led the project here, working with the Safe Haven. Milan Markovic is our computing science genius, keeping us right on like how we might actually create some of these knowledge graphs for provenance and stuff. Helen Rowlands works like on the other side of the data. So she's the one that can actually see how the processing happens and explain it to us before we get it. And I'm the researcher who's like at the back end going, wait, what? How does this work? So I'll basically hand it off. I just had one more slide. So the Safe Haven is run between the university and NHS Grampian. We often don't credit NHS Grampian in these types of research talks as much as we should. The bulk of the funding is from Wellcome Trust, but we've also been supported by the Health Foundation by their networked data lab. So that's all I wanted to say, and Bernhard will take it over and talk to you about his process.
Thank you for the introduction, Jess. And as Jess mentioned, we want to talk to you today about openly reporting data provenance in a high security setting or environment. And first, I think it's because if we just talk about a few of the basics and some concepts before we go into the deeper subject of it. So what is data provenance? Data provenance is the documentation of where data comes from, which processes have been used to process the data and which methods were involved in the process of generating that data. In the UK, researchers have access to routinely collected data from the NHS and other government agencies, but this data need to be protected, or the individual in this data need to be protected. Their privacy needs to be protected by as it is a government requirement. And so that means that the researcher only gets a small project-specific proportion of the data. And that proportion is also anonymized so that the privacy and the identity of the people in those data sets are protected. And for the researchers or for the research project using such data to work on their data safely, they can use they need a secured setting to work on that data, and those secured settings are data safe havens. They are specialized secured environments which are supported by trained specialized staff who process and link that data to other data sets. And then inside this secured setting, the data is made available for research while still protecting the patient's identity and privacy. So if you want to visualize this, you can think of something like that glove box, and the researcher has access to the data, but he is incapable of taking anything out of that glove box or putting anything new in it. But he can do everything else he can do with the data inside that glove box, so he can research it and work with it. And for those research projects, the research data is often linkage data or called linkage data. And what linkage data is basically that's a data set that has been generated by connecting or linking two different data sets together and creating a linkage data set. And that connection between those data sets are patients or individuals. So, for instance, you can use patient hospital visits and link that to the patient's prescription data. Then, and then your linkage data set would be all the hospital visits of the individual patient, as well as the prescription they have gotten over the period of time, or the time frame you're looking at. And then if you think about this, that means that the data linkage process is the foundation of each research project that uses linkage data. And one of the crucial things about this is that currently researchers are unfortunately relatively blind to that process. For them, it's a black box because very little information is provided to the researchers on the methods that were used to produce their data set. All the researchers really know is I'll provide my inputs here. I'll tell what kind of cohort I want, and I'll say which data sets I need. Then the information wanders into that black box, and maybe weeks later they get a data set release, but they don't know how that happened. And there's a problem with it, and that's the lack of transparency, which results into an increased risk of undetected errors programming, but as well it makes it difficult for the research community to actually evaluate those research projects or even reproduce the research because they don't know how the data linkage was done. They don't know how some of the fundamentals of that research project was conducted. And that's not just the fear of the undetected error is not just a theoretical fear. It did happen to one of our fellow researchers here at the university, where the research data for her PhD project was wrongly linked, and it was only discovered after she had submitted her PhD. And this can have severe impacts on researchers' careers or researcher in general. She got off lucky as she only needed to pull out of conference and just reanalyze a few bits of her data again. But this is like I said, it just got lucky. But imagine this happens a few decades from now when you already conducted plenty of research and then you find out, oh, something really significantly went wrong there. So what had happened in her case? During the data linkage process, there's a step where all the original patient's IDs are replaced with new anonymized identifiers for each data set. And each data set and each patient gets a unique ID. And this is to prevent premature linkage of the data. But to be able to later then generate that linkage data set, you need to know which of these unique IDs belong to which patient ID, right? So you need a mapping table or a spreadsheet that tells you which IDs are linked to each other. And in the case of our researcher, that mapping table had been accidentally manipulated. So the result of this was when this mapping table was used then to conduct a data linkage process and link the two data sets together, the data from the yellow patient in data set 1 was linked to the data from the blue patient of data set 2. The light blue patient, all their records were nicely connected, but then for the pink patient, the data from data set 1 was linked to the data from the yellow patient from data set 2. And this had happened without that the researcher was aware of this. So they are expecting, or they seeing their data and they're trusting the process because they don't have any other means of knowing what had happened. They just get the data and says, that's it. And they're basically expecting this nicely sorted bookshelf. But in reality, if you look behind the bookshelf, you see that it's not so neatly sorted as expected. But then again, these errors are almost impossible for the researcher to detect, especially if they don't have any overlapping variables. They just get their data. So then we thought, okay, how can we try to make this process more transparent, or how can we tackle this lack of transparency? And we decided, okay, we need to create a shared understanding of what's going on. And the best way to do this is by generating an ontology, because an ontology allows you to formalize and explicitly define shared conceptualizations. And you also do this by engaging with stakeholders. So we conducted interviews with researchers, we talked to the analysts and everybody who's involved in the data linkage process to get a general understanding of the whole process and what is needed and what we want to get out of the whole process. And then additionally, we also need a tool to be able to capture what we're looking at and to capture the process. But as I mentioned, we also need somebody who understands the black box, who knows the process inside the black box we want to investigate. And even better, we needed somebody who has access to the process, but also is just starting to learn the process. So they look at it with the same fresh and naive eyes that we had, and we're asking the same questions we were asking, compared to somebody who is maybe already working for years in the data safe haven and is sees some of the steps as trivial. So this is where Helen came into play, and Helen and I had tons of meetings and discussions to map out the process and understand the data linkage process. And as a tool for that guided us throughout the mapping of that process, we used Prof.O, because Prof.O is sort of considered a lightweight ontology, and it allows to be adapted over a wide range of application. Provides you with a general set of classes and properties. So you have three classes. You have agents, entities, and activities. An agent is something that bears some form of responsibility for an activity taking place. So that can be a person, an organization, or even a software. Then you have an entity. An entity is a digital physical thing or concept, and that's things like images, databases, data sets, you name it. And the activity, that's something that occurs over time and acts upon an entity. So an activity can either consume an entity, can process it, transform it, or even generate an entity. Then you use the object properties to connect pairs of individuals or classes with each other. And you use the data properties to connect individuals to literals, or rather data values. And your individuals are then the actual objects within your domain or your class. I'll explain this in a second in a bit more detail. So this is what a very simplified version of a Prof.O model would look like. And in data provenance, you always look at what you have in front of you and then go backwards to its origin, hence the arrows pointing to the data source instead of what you're actually having in front of you. So here in this model, we have one agent, that's our lead analyst. We're having two entities, that's our database and our data set, and we're having one activity. And the green arrows represent our object properties, which are connecting those classes. So our data set was generated by the data selection activity, and the data selection activity used the database. The data selection activity as well as is also associated to our lead analyst. And now within the ontology or within Prof.O, you can automate some of the data properties and infer some of them automatically. For instance, you can then automatically say that if that the data set was derived from a database and that the data set was attributed to our lead analyst. And then when we now look at the data properties, those are things you would expect your individuals in the different classes to have. And your individuals are then the actual object that you want to represent or that you have in the real world. So for databases, that could, for instance, be the SMR00 outpatient database, or the PSI database. And then you would expect, or then within the model, you would have the name, the version, and the data custodian of those data sets. Or if we're looking at our lead analyst, where Helen is our instance or our individual of a lead analyst, we would then expect to have her name and her email address as well available. As well as available. And so after familiarizing ourselves with the with Prof O, Helen and I used this to capture and describe the data linkage process. And you can see it's a multi-step process which is highly complex. And here we are actually using a very, very simple example where don't try to see what's actually happening here. It's just as a demonstration on the complexity of it. But here we're actually just using a very simple example where a research project just wants two databases or two data sets from two databases to be linked to each other. And that's just everything that goes into it for just linking two data sets to each other. After mapping this out, we were able to kind of create a more simplified view to make it a bit more easy to explain what's actually happening. So for the data linkage process, you have two separate IT systems. You have an NHS managed system and you have a data safe haven managed system. You have 3 to 4 agents interacting in that process. So you have the lead analyst on the NHS side, which has access to the raw identifiable data. They are doing the data extract or the record extraction based on the definitions provided by the researcher. So on the cohort, based on the cohort definition and what data sets the researcher wants. Once the data has been extracted, the lead analyst is anonymizing the identifiable data, and then they are anonymizing the identifiable IDs. Then they pass their work to a second analyst who does validation checks on the work. And once the work passes the validation checks, it goes to the technical lead of the safe haven, who does the disclosure checks that all the permissions are in place and everything else. Then if they pass step 5, the data is securely transferred to the data safe haven site, or to the data safe haven managed system. And this is then where the lead analyst creates a common unique identifier for each patient throughout each of the data sets, so that the data actually can be linked together and the researcher can use the data from the different data sets and can knows which data belongs to which of the cohort, to who of the cohort. Then that work is again goes through a validation check and goes through a disclosure check. And only then it is passed to the researcher. And in this process, at any point, if the work of the lead analyst doesn't pass a validation or a disclosure check, it can jump back to step 1 or to any other given step wherever somebody felt like, okay, that needs to be redone and reevaluated. So potentially multiple iterations of this process before that data actually arrives at the researcher's research folder. Why is this helpful? Not only to giving me a dry mouse, but it's also good that to define a standardized process, because it will help both. It will help the researcher and the analyst to talk to each other and communicate and specifically discuss certain steps of the process. It will provide, or does provide, more transparency and a better understanding for the researcher on what work is actually needed and what processes are involved in the data linkage process. And it also allows the researcher to report it. It will also help to potentially identify accidental inconsistencies in some of these steps. From an analyst point of view, there are also advantages to this, because currently an analyst, all of the checking and reporting is done manually, and some of the file-based reporting is susceptible to editing with very minimal logging. So with the use of the ontology framework we're suggesting, that would allow for automation and streamlining of this logging and checking process. It provides a standardized language which can be adapted across teams or across data safe havens potentially. And it will also allow or free up the analyst to concentrate more on the technical aspects rather than on filling out reports and doing all the checking manually. So to create our ontology, after we did the whole mapping of it, we needed to translate this detailed mapping process into Prof.O. And and also we needed to expand the relatively generic Prof.O vocabulary with death specific vocabulary. And then this is why we created the Prof.O extension Safe Haven Provenance. And Milan will now in a second show what you can do with the Prof.O extension we created. And just for the example Milan wants to show, I'll just give you a few core values. So we assumed a cohort size of 50,000 patients. The two databases used were the SMR00 outpatient attendance and the PSI prescription database. And the variables we wanted to extract were A, B, and Z. For the SMR00 and for the PSI, it was X, Y, and Z. And I'll pass to Milan.
Thank you. Now, so I'm sure you are all properly confused by all the technical terminology by now that Bernhard has been talking about. So I try not to confuse you even more, but let's just focus on the generics, why we using this technology. Because essentially what we want to capture is the audit trail, right, of what happened. Things are getting created from different places. We have different databases going on. We've got different versions of data sets that are going through different processes and then are getting turned into different files. So there's a lot happening there, and that's why we created this controlled vocabulary, which we described as an ontology. But you might ask, why do you need an ontology? Can I not just stick it in a table? Can I not just put in an Excel spreadsheet? Yes, you can. But the problem with that is that your columns are now essentially deciding what is kept in that in those table cells underneath. They are decided by you. It's not a commonly agreed sort of schema that you would use. And so if you use like a SQL table to log all this information, it will be up to the person that is developing the schema for the database, how essentially the knowledge base will look like, how the information will be captured. So instead of putting everything in a tables and linking the tables together, we put everything in a graph. So after you end up populating the ontology with different individuals that represent the particular processes and the entities that occurred at a certain point in time, you will end up with a big graph, which we call knowledge graph. And as you can see, even with a simple example like Bernhard was describing, we'll end up with quite many things, because for each individual we will link it to the type, which is defined in ontology. We annotate it with different human readable data, like comments, to explain to the human user what this individual is representing. We can associate with another pieces of information like the timestamps or file names and so on, right? So we break down all this information into these little pieces and we'll link it all together. So for example, here we ended up with 81 different classes, different types of the data, 87 instances, we have 77 links, we have over 1,700 axioms, which are the facts that we can retrieve from our knowledge graphs. And we can even get more of these facts, because this is when this technology gets cool, right? Because everything is linked together and described using a standard vocabulary. You can design rules that then understand the structure of our data and they can infer new facts, right? So just to give you an example, if we were modeling a domain that is describing family members, you know that you have a father or parent, and you know that you have a child, right? And you link, let's say, a child to a particular parent through a relationship. And now, let's say you know more information about the child. Let's say a gender, right? So we know that it's a female, and we can have a rule that goes over all instances in our graph that meet the criteria where the instance is a child of a parent and has a gender female, and we can create new relationship between the parent and the child called has daughter, right? And we can ask different queries now. We can ask how many daughters does this particular parent have? And this information wasn't available to us before, but we could infer it through the automated rules, right? And this is just because the computer that is helping us to process the information now understands the structure of the data. It understands what the concepts mean. So obviously we don't want to explore this information by looking at the interconnected graph. So what we need is the graphical visual representations of this data. And to create those, we can use, I don't know if you're familiar with the SQL databases. When you're extracting data from a SQL databases, you write SQL queries, right? So for this graphs, we have something similar, which is called Sparkle, where you can define your queries that define a certain pattern that should be matched over the data captured in a graph, and all the data that is matching this pattern will be returned for these variables that you're looking for. So this is how you get the data from the graph, but you can use the same language to do some clever stuff on the background. So for example, you can compare the variables that you're looking at, right? If you want to say that a certain variable always has to be greater than the other variable, and if that's not the case, you want to create a new knowledge which will tell us, which will identify an error, essentially, right? So these rules can be applied to the graph, they traverse the data, and if there is something wrong, we get the results back identifying the errors. And this is exactly what we try to leverage in our user interface, where we designed two reporting templates, one for the analysts and one for the researcher. And we designed it in a form of a list of questions that the analysts and the researcher might want to know answers to when they are sort of auditing the process, the data linkage process that the data went through, right? So I will show you a live demo in a minute, but basically you are looking for some basic information like did the number of data in this particular dataset file change when it went through the process, when it shouldn't have, right? Because if it had changed, it might mean that we unintentionally lost parts of the data and something went wrong in that process, right? So, as I said, I'll demonstrate this in a minute, and this is basically what we did in our project. Okay, I can do it now. Let's see if this works. So this is what you would get if you were an analyst and you were using our tool, right? So you have 19 questions to which you can see the answers, which are these tables populated with the data retrieved using Sparkle queries from our knowledge graph. So this is all the information captured in our knowledge graph. You have things like who was involved. So we know that Helen, Joanne, and Milan was involved. They have different roles, analyst, research coordinator, and so on. We are interested in knowing whether the cohort specification used by the analyst matched the cohort specification requested by the researcher, because that's quite an important thing to know as well, because the researcher defines this as a free text, whereas the analyst has to translate it into some sort of select query or even a series of these queries. So there can be some discrepancies between the understanding, right, of the analyst and the research of what researcher has written and what analyst did in the end. So we want to know what came from where is everything stored, who are the people that we can contact when we have some questions about the data sources, the different versions of the data sources that we were using, because if you want to reproduce the experiments later, the data sources might have changed. They can contain more data and you might get different results. How many people were in a cohort? Yeah, how many people were linked and not linked? And here you can see that this is the implementation, example implementation of these rules that we can run over certain questions, and they can tell us when something looks suspicious. So here we manually inserted an error where the number of people that were linked, number of cohort members that were linked, and number of cohort members that were not linked doesn't match the overall cohort size. So the interface is telling us automatically that might be something wrong, right? Because some of these files at certain point might gotten changed, and it is not what we necessarily want, right? The same is done with the number of records. This one is asking about whether the data sources that were defined in our data linkage plan, whether there are indeed records, whether there is an audit trail that would confirm that all these data sources were used to produce some sort of data that were then linked later on. Yeah, and here we have another demonstration of a rule that discovers that one of the data sources defined in our data linkage plan was never used because there is nothing ever derived from that data set. So I'll just go back to the presentation and take us to the last slide. So basically, where do we go from here, right? And why is this important, what we did? Is this of any use? Well, we sort of started from the end. We have the visualization interface, and we have the middle part, which is the ontology, which allows us to describe information, right? But what we did for this project, we created our knowledge graphs manually. So we populated the ontology manually. As we all know, nobody wants to keep lots of records, right? At least I'm not the kind of person that would be intrigued by writing down everything what I do, right? So, and for that reason, the data collection of provenance information is a very daunting process, and it's also a very error-prone process. So, in ideal world, we would record all this automatically. However, this is not always possible. So what we suggest for future, we need to focus on developing new tools that can help us to record this information at least semi-automatically, right? So now I'm talking about the type of information that can be extracted easily from a files. Let's say number of rows. You don't need to enter that manually. You don't need to open an Excel file and count the number of rows. You can have a script that does that for you, right? But for some things, like the rationale of the analyst, why did they think that this is the correct representation of the cohort specification, we possibly will have to rely on manual inputs from the analyst because it would be really difficult to extract this information manually, right? So we will end up with a mixture of semi-automated and manual input tools. Could be a website that is generated automatically from the data linkage plan even. So we can still leverage the structure of the information that we are recording, even to help us to generate these manual input interfaces. But I don't think it's going to be ever fully automated. And of course, we need to do more experiments and testing we need to try to describe more research projects to make sure that our ontology is sufficiently covers the domain that we're trying to model. And we need to speak to more experts. Perhaps even the reports for the analysts and researchers will evolve over time because we might have missed some important information. But the main thing is that the key elements of this infrastructure have been created by this project. So we can just keep on expanding and extending these tools.